There is something quietly comforting about lying still in the dark and realizing that above you, past the ceiling, past the clouds, past everything you can see or name, the universe is simply enormous. Welcome back to Sleepy Science. If this is your first time here, I hope you stay a while. If you enjoy what we do, a like and a subscription mean the world to us. And if you drop a comment letting us know what topic you want to sleep to next, we will do our best to make it happen. And if you ever want to help keep these videos alive, you can find our Patreon quietly waiting at Sleepy Science. Tonight, we are going to drift together into one of the oldest and softest questions a human being can ask. Are we alone in the universe? Let your body settle. Let your shoulders drop. There is nowhere to be but right here. The universe is approximately 13.8 billion years old. Write that number out in your mind. 13.8 billion. Most of us have heard that figure before, but it rarely lands the way it should. For context, our own sun did not exist. For the first 9 billion of those years, the Earth itself has only been here for about 4.5 billion years. Which means that before our world was even born, the universe had already been running for nearly as long again. Long enough, perhaps, for other worlds to have formed and aged and grown quiet long before our sun ever caught fire. That thought is worth holding gently. There are roughly 2 trillion galaxies in the observable universe. 2 trillion, each one containing hundreds of billions of stars. The Milky Way alone, our own galaxy, holds somewhere between 100 billion and 400 billion stars. And around many of those stars are planets. Some warm, some cold, some wet, some bone dry. The sheer number of worlds that exist, just in our one small corner of creation, is a number too large for the human mind to truly absorb. We discovered, not so long ago in the grand scheme of things, that other stars have planets orbiting them. The first confirmed exoplanet, a planet around another star, was discovered in 1992. Not even 40 years ago. For most of human history, we simply had to wonder whether the stars above us held worlds of their own. Now we know they do. We know it the way we know the ground is beneath us. As of today, astronomers have confirmed more than 5,500 exoplanets. And that is only what we have been able to detect with the instruments we currently have. The true number is almost certainly vastly larger. Breathe in slowly and out. One of the most important measurements astronomers make is something called the habitable zone. It is the region around a star where a planet could, in theory, hold liquid water on its surface. Not too hot, not too cold, just a narrow band of warmth, where the conditions for life, as we know it, might be possible. Some scientists call it the Goldilocks zone, a quiet place, not too far from the fire, not too close to the cold, where something soft and living might take root. What is remarkable is how many planets seem to fall within that zone. Estimates suggest that in our galaxy alone, there may be tens of billions of rocky planets sitting in the habitable zones of their stars. Tens of billions, just in our galaxy, among 2 trillion. The mathematics of loneliness, when you look at it that way, becomes almost impossible to defend. And yet, we have not heard a word. Not a signal, not a beacon, not a whisper from another mind, drifting through the dark beside us. This puzzle has a name. It is called the Fermi Paradox, named after the physicist Enrico Fermi, who, during a lunchtime conversation in 1950, paused and asked simply, "Where is everybody?" If the universe is so vast, and so old, and so full of worlds, then where are all the others? Why haven't they arrived? Why haven't they called? That question has no clean answer. And in some ways, that is exactly what makes it so beautiful to sit with. As you lie here in the dark, let your hands relax, your fingers, your palms. Let everything soften. Water is one of the great clues in the search for life. Here on Earth, wherever there is water, there is life. In the deepest ocean trenches, where no light has ever reached, life is there. In boiling hot springs, in frozen glaciers, in the cracks of dry desert rocks, wherever water exists. Even in trace amounts, something living finds a way. This makes water one of the most important things astronomers look for when studying other worlds. Europa is one of Jupiter's moons. It is a world covered in ice, smooth and pale and faintly cracked, like an old ceramic bowl. Beneath that ice, scientists believe there is a liquid ocean. Not a small pool, an ocean. One that may contain more liquid water than all of Earth's oceans combined. And at the bottom of that ocean, there may be hydrothermal vents, similar to the ones we find on our own seafloor, where heat and chemistry mix in exactly the kind of way that, on Earth, gave rise to some of the earliest forms of life. Enceladus is another moon, Saturn's moon. Small, bright, and somehow quietly extraordinary. Through cracks near its south pole, Enceladus actively shoots plumes of water vapor and ice particles out into space. When the Cassini spacecraft flew through those plumes, it detected water, hydrogen, carbon dioxide, and organic molecules. The building blocks, the quiet ingredients of something living, right there, drifting into space, from a moon most people have never heard of. There is something that astronomers call organic chemistry. It refers to the presence of carbon-based molecules, the same kind that form the building blocks of life on Earth. What is quietly remarkable is how common these molecules are across the universe. They have been found in the dust clouds between stars, in asteroids, in meteorites that have fallen to Earth, in the atmospheres of planets and moons far from our own. The chemistry of life does not seem to be some special gift given only to Earth. It appears to be written into the fabric of the universe itself. That is worth pausing on. Your breath is slow and even. The room around you is still. There is nothing you need to do right now, except rest. Mars is our nearest neighbor, in the direction of cold and dust. Once, billions of years ago, Mars may have been warm. It had rivers. We can see the ancient riverbeds now, carved into the rust-colored rock. It may have had a thick atmosphere, oceans even. Something happened, slowly, over a very long time, and Mars grew cold and thin and dry. But in that ancient window, when Mars was warmer and wetter, could something have lived there? Could microbial life, something small and patient, and entirely unaware of its own existence, have taken hold in those ancient waters? We do not know yet, but we are looking. Carefully, quietly. The rovers we have sent to Mars are among the most patient travelers humanity has ever made. They move slowly across the red surface, drilling, sampling, analyzing, sending their findings back across millions of miles of empty space. There is something almost meditative about imagining them out there, rolling gently in the silence, doing their patient work, while the rest of us sleep. The search for life beyond Earth has its own formal name. It is called astrobiology, and it is a genuinely young science. For most of human history, the question of life elsewhere in the universe belonged to philosophy, to religion, to storytelling, to the quiet midnight thoughts of people lying exactly where you are lying now. Only in the last few decades has it become something you could study in a laboratory with instruments and data and careful hypotheses. The universe, so to speak, is only now being asked the question in a language it can answer back. One of the most famous events in the history of this search happened in 1977. A radio telescope in Ohio picked up a signal that lasted exactly 72 seconds. It was so unusual, so unlike any known natural source, that the astronomer who found it wrote the word "Wow" in the margin of the printout. We have never heard it again. We do not know what made it. It might have been something entirely natural, a quirk of hydrogen, radiating from somewhere in the stars. But for a moment, a very quiet moment in 1977, someone looked at a piece of paper and wondered whether they had just heard another voice. Let your eyes close a little more. There is no hurry here. The night is soft and long and entirely yours. There is a number that scientists use when thinking about the probability of intelligent life in our galaxy. It is called the Drake equation. In 1961, an astronomer named Frank Drake wrote out a simple formula for estimating how many communicating civilizations might exist in the Milky Way right now. The equation multiplies together a series of probabilities. How many stars form each year? What fraction have planets? How many of those planets could support life? How many actually develop life? How many develop intelligence? How many build technology? And how long those civilizations last? Change any one of those numbers, and the answer shifts enormously. Some estimates suggest thousands of civilizations. Others suggest we might be alone. The equation does not resolve anything, but it does something important. It turns a vague feeling into a structured question. And structured questions, in science, are the beginning of everything. We have sent physical objects out of our solar system. 2 of them, actually. Voyager 1 and Voyager 2, launched in 1977, are now the farthest human-made objects in existence. Both of them carry golden records, discs etched with sounds and images from our world. Music, greetings in 55 languages, the sound of rain, the sound of surf, a mother kissing her child. They drift now in the darkness between the stars, carrying a message from a species that was not entirely sure whether anyone was listening. The chance that they will ever be found is vanishingly small, but they were sent anyway. Because sometimes the gesture is the whole point. There is a concept in the search for life called biosignatures. These are signs in a planet's atmosphere or on its surface that could indicate the presence of living things. Oxygen, for instance, is a biosignature. Here on Earth, oxygen is constantly being consumed by life and constantly being replenished by life. Without biology, our atmosphere would run out of free oxygen relatively quickly. So, if we detected a planet with large amounts of oxygen in its atmosphere, that would be a quiet clue. Not proof, but a clue, a whisper in the data, that something might be breathing. Methane is another biosignature. On Earth, most of the methane in our atmosphere is produced by living things. Cows, wetlands, the quiet decomposition of ancient organic material. If another planet showed methane and oxygen together, that would be especially interesting because these two gases react with each other over time. Something would have to be continuously producing them both to maintain that balance. And the most likely candidate for something doing that is life. The James Webb Space Telescope, which began science operations in 2022, is capable of doing something remarkable. By observing a planet, as it passes in front of its star, it can analyze the light that filters through the planet's atmosphere. Different molecules absorb different wavelengths of light. So by studying that filtered light carefully, scientists can begin to determine what gases are present. We can, for the first time in human history, begin to read the air of worlds we will never visit. That is a quietly extraordinary thing to hold in your mind as you drift towards sleep. Let your jaw go loose. Your neck, the space between your eyebrows. Just let it all soften and rest. Astronomers have found planets where it may rain glass, not water, glass. Silicate particles driven by winds of more than 2,000 kilometers per hour. They have found planets denser than lead, planets made almost entirely of diamond, planets where the night side is so cold that whole atmospheres simply freeze and fall to the ground each winter. The universe is stranger than the strangest story anyone has ever told about it. And in all that strangeness, it is worth considering that life here on Earth is itself rather strange. Extremophiles are organisms that live in conditions we would consider entirely impossible. Tardigrades, sometimes called water bears, are microscopic animals that can survive in the vacuum of space. They can withstand radiation doses that would be lethal to any other animal we know. They can be completely dried out, frozen, boiled, and brought back to life. If something as resilient as a tardigrade can exist here on Earth, it becomes much harder to rule out life in environments we once thought too hostile to support it. There are bacteria on Earth that live inside solid rock, miles below the surface, where no sunlight has ever reached. They do not eat sunlight. They eat chemicals, hydrogen and sulfur, leaching out of the stone around them. They are, in a sense, completely independent of the sun, which raises a gentle question. What if life on other worlds is just as creative? What if it found an energy source we haven't thought to look for? What if the biology of another world is so different from ours that we would not recognize it, even if we were standing in the middle of it? This is one of the great challenges of the search. We are looking for life, but we are mostly looking for life that resembles us. Carbon-based, water-dependent, breathing something recognizable. Life on another world, if it exists, might be made of entirely different chemistry. Silicon-based, perhaps, or something we haven't imagined yet. Something that evolved in an ammonia ocean, or in the upper clouds of a gas giant, or somewhere so alien to our experience that no human word would currently fit it. And yet the thought of it is peaceful somehow. The idea that life in whatever form, might be woven into the fabric of the universe, the way water is woven into the fabric of a cloud. Your body is heavy now, heavy and warm. Let the weight of you sink down into wherever you are lying. Venus is sometimes called Earth's twin. It is almost the same size, almost the same mass, formed at roughly the same time, from the same solar material. And yet, Venus today is a world of crushing pressure and acid clouds and surface temperatures hot enough to melt lead. A twin that went a different way. But here is an interesting note. Some scientists have suggested that in the upper atmosphere of Venus, where the pressure eases and the temperature becomes more moderate, there might just be conditions where certain types of microbes could, in theory, float and survive. It is speculative, but then much of the most interesting science is. In 2020, a team of astronomers announced they had detected a gas called phosphine in the clouds of Venus. Phosphine, on Earth, is associated with biological processes. The discovery caused quiet ripples through the scientific community. It was later disputed. The data was re-examined. The picture became more complicated. That is how science often works. An announcement, a challenge, a revision, a deeper look. Not a clean story with a neat ending, but a slow and patient unraveling of something that was never simple to begin with. SETI stands for the Search for Extraterrestrial Intelligence. It is an organization and a field of research dedicated entirely to listening. For decades, scientists at SETI have pointed radio telescopes at the sky and listened for signals that might carry the shape of intention. A pattern, a rhythm, something that could not have been made by a star, or a nebula, or a pulsar's precise spin. Something that carries the signature of a mind. It is one of the quietest jobs in science. You sit, you listen, you wait, you analyze vast amounts of noise, looking for the one thing that should not be there. And so far, the noise is all there is, which might mean nothing, or it might mean everything, depending on how you look at it. The speed of light is another thing worth sitting with gently. Light travels at roughly 300,000 kilometers per second. It is the fastest thing in the universe. And yet, even at that speed, it takes light from the nearest star to Earth about 4 years and 3 months to arrive. 4 years of traveling at 300,000 kilometers per second, just to reach the next star over. The nearest star, the one closest to us. And beyond that, the distances only grow. The center of our galaxy is about 26,000 light-years away. The nearest large galaxy to ours, the Andromeda Galaxy, is approximately 2.5 million light-years away. When you look at Andromeda in the night sky, the light entering your eyes, left that galaxy 2.5 million years ago. Before our species existed, you are looking back in time, without a machine, just lying here, looking. This means that even if another civilization were trying to contact us right now, the message might take millions of years to arrive. And similarly, any signal we send would not reach even the nearest stars. For several years, communication across the cosmos is not a conversation. It is more like writing a letter. You know the recipient will not read for a very long time. There is something curiously tender about that thought. The universe has what scientists call a cosmic microwave background. It is a faint glow of radiation that fills all of space, left over from the earliest moments after the universe began. It is the oldest light there is, a whisper from when everything was young and hot and dense, and just beginning to expand into what it would become. When you hear that this background radiation is visible in every direction you look, there is something quietly settling about it, as if the universe itself is still murmuring to itself about how it all started. The atoms in your body were made inside stars. Most of them, anyway. The carbon, the oxygen, the calcium, the iron in your blood. These elements were forged in the interiors of massive stars that lived and died before our sun was born. When those stars exploded in supernovae, they scattered their material across the surrounding space. That material eventually gathered into clouds, and those clouds collapsed into a new star, our sun, with planets forming in the disk around it. And one of those planets, this one, eventually grew quiet enough and warm enough for chemistry to discover how to copy itself. You are made of stardust. That phrase is so often used that it risks sounding empty, but it is literally true. The atoms you are made of have drifted through nebulae. They have been part of stars. They are older, most of them, than the Earth itself. And they were here, doing their atomic business, long before you arrived to inhabit them, and lie here, wondering about the dark. If life arose on Earth from the chemistry of an early, turbulent planet, there is a thought that follows naturally from that. Panspermia is the idea that life, or the seeds of life, might travel between worlds. Not on spaceships, not with intention, but carried inside rocks. When a large asteroid or comet strikes a planet, with enough force, it can blast chunks of rock into space. Those chunks can travel for millions of years before landing on another world. And if those rocks contain dormant microbes, sealed inside, protected from radiation by the rock around them, those microbes might survive and take hold wherever they land. Life, according to this idea, might be scattered across the cosmos, like seeds on the wind. Mars and Earth have exchanged material this way. We know this because we have found meteorites on Earth that originated on Mars. They were blasted off the Martian surface, drifted through space, and eventually fell through our atmosphere. One of those meteorites, found in Antarctica in 1984, was studied in 1996 and seemed to contain structures that some scientists argued looked like fossilized microbial life. Others disagreed. The debate continues quietly to this day. But the mere fact that the question can be asked seriously by serious scientists says something. Your breath is slow. In and out. In and out. Let your thoughts drift like smoke. There is a telescope array called the Very Large Array in New Mexico. It consists of 27 large radio dishes spread across the desert, all working together to form one enormous ear pointed at the sky. You may have seen images of it. The dish is white and precise against the pale desert sky. It listens for signals from distant galaxies, from black holes, from the remnants of supernova explosions, and from the quiet spaces between. When I imagine it at night, the dish is tilted softly toward the stars. I find something restful in the image. 27 enormous ears, all listening, all patient, all perfectly still. The Allen Telescope Array in California was built specifically for SETI research. It can simultaneously survey large regions of the sky for radio signals, while also conducting ordinary astronomical research. The idea is to make the listening part of the background, part of the ongoing work, rather than a separate enterprise. To build listening into the ordinary rhythm of science. If another civilization is broadcasting a signal, we might ask, what kind of signal would we recognize? We tend to focus on radio waves because they travel well through space. They are cheap to produce, and they are the kind of thing a civilization, at roughly our stage of technological development, might use. But a civilization significantly more advanced than ours might communicate in ways we simply haven't thought of. Light pulses, neutrinos, something we haven't discovered yet. Listening with radio telescopes might be a bit like searching for a conversation by looking for smoke signals. Right idea, wrong medium. There are stars called red dwarfs that make up about 75% of all the stars in our galaxy. They are smaller and cooler than our Sun. They burn very slowly. Some of them will last for trillions of years, far longer than our Sun will. And many of them have rocky planets in their habitable zones. TRAPPIST-1 is a red dwarf star, about 40 light-years away. It has 7 rocky planets. 3 of them are in the habitable zone. 3. All in the same system. all potentially with liquid water. When that was announced in 2017, it was quietly significant. 40 light-years is not far. In cosmic terms, it is not the next-door neighbor, but it is close enough that one day, with instruments not yet built, we might be able to look at those planets and read their air. There is something called the Great Filter. It is a hypothesis proposed to help explain the Fermi paradox. If the universe is so vast and so old, why is it so quiet? The Great Filter suggests that somewhere in the journey from simple chemistry to interstellar civilization, there is a step that is extremely difficult to get through. A filter, a bottleneck, a barrier so hard to cross that almost nothing makes it. The question that follows is both hopeful and unsettling. Is the filter behind us or ahead of us? If the filter is behind us, if the hard part was the emergence of complex life, or consciousness, or some other step that we have already somehow managed to cross, then we may be genuinely rare. We may be among the first complex civilizations to have made it this far, which is humbling in a particular way. But if the filter is ahead of us, if some civilizations do reach our stage and then tend to destroy themselves, or be destroyed before they can spread across the stars, then the silence of the cosmos takes on a slightly different feeling. There is no answer to that question yet, and in some ways, lying here in the quiet, the question itself feels more important than any answer would. The atmosphere of Earth extends about 10,000 kilometers above the surface. Most of what we think of as our sky, the part with weather and clouds and birds, exists in just the bottom 12 kilometers or so. The atmosphere becomes thinner and colder and stranger as you climb through it. And then, eventually, it just becomes space. There is no hard line, no wall. The Earth simply, gradually, lets go. And it is in this thin and fragile wrapping that all of us exist. Every person who ever lived, every animal, every plant, every microbe, every thought and painting and song, all of it in this impossibly thin layer on the surface of one planet, orbiting one star, in one small region of one galaxy among 2 trillion. And perhaps we are the only ones. Or perhaps the galaxy is full of quiet voices, and the universe is simply too large for them to reach each other yet. Let your legs relax, your feet, your toes. Let your body grow still and heavy and warm. Black holes are one of the strangest things in the universe. They form when a massive star collapses at the end of its life, compressed down to a point of such extraordinary density that nothing, not even light, can escape its gravity. The boundary around a black hole is called the event horizon. Cross it, and there is no return. Even information, in the theoretical sense, cannot escape. A black hole keeps its secrets. Most large galaxies, including our own, have a supermassive black hole at their center. The one at the center of the Milky Way is called Sagittarius A star. It has a mass of about 4 million times the mass of our Sun. And yet it sits quietly at the heart of our galaxy, about 26,000 light-years from here, pulling very gently on everything around it. In 2022, astronomers captured the first direct image of it, a fuzzy ring of orange light around a dark center, the shadow of something so massive that it bends the light of the galaxy around itself. Dark matter is another quiet mystery. It is a substance or a phenomenon that we cannot see directly, but whose gravitational effects we can observe. Galaxies rotate in a way that does not match the visible matter inside them. They spin too fast for the stars and gas we can see to account for. Something else must be there, providing extra gravitational pull. We call it dark matter, and it makes up about 27% of the universe. We do not know what it is. We cannot see it. We cannot touch it. But the mathematics of the universe insists that it is there. And then there is dark energy. An even stranger thing. It is thought to make up about 68% of the universe. It is the force, or property, or perhaps something entirely else, that is causing the expansion of the universe to accelerate. Not just expand, accelerate. The galaxies are moving apart, and they are moving apart faster than they were before. Something is pushing, or pulling, in a direction we do not fully understand. If dark matter and dark energy together make up 95% of the universe, that means everything we can see and touch and measure, every star and planet and nebula and black hole, is only about 5% of what is actually there. 5%. We know 5% of what exists. The universe is 95% mystery. And somehow that feels less alarming and more restful the longer you sit with it. Breathe. Just breathe. The first living things on Earth appeared roughly 3.5 to 3.8 billion years ago. They were simple, single-celled, probably living in warm, shallow seas or near hydrothermal vents. For about 3 billion years after that, life on Earth stayed simple. Just cells. No brains. No eyes. No lungs. No hands. Just chemistry, patiently doing its work, generation after generation, making copies of itself and slowly changing. Complex life, multicellular life, only appeared in roughly the last 600 million years. Intelligence, in the sense that you and I would recognize, in the last few 100,000. The window of time in which a civilization like ours could have existed is very narrow compared to the age of the Earth. Now imagine that curve applied to other planets. Some of them, formed billions of years before Earth, might already have had their window, might already have risen and fallen and gone quiet in the time it took our planet to even form. The universe is old enough to have already told stories that no one alive today will ever hear. There is something called the pale blue dot. It is a photograph taken on February 14th, 1990, by the Voyager 1 spacecraft as it was leaving our solar system. At the suggestion of astronomer Carl Sagan, mission controllers turned Voyager 1 around and pointed its camera back at Earth from a distance of about 6 billion kilometers. In the photograph, Earth is a tiny point of light, a pale blue dot, barely visible against the vast darkness. Carl Sagan wrote about that image in a way that has been read by millions of people and still sends a soft chill through anyone who truly absorbs it. He noted that every king and peasant, every saint and sinner, every inventor and explorer who ever lived their entire life on that speck. Our planet is a small thing in an unimaginably large place. And knowing that does not make us smaller. It makes everything we share here feel a little more worth holding. Your eyelids are heavy now. That is perfectly fine. Let them be heavy. Astronomers study something called stellar spectra. Each element, when it burns or absorbs light, does so at a specific wavelength. Like a fingerprint, sodium burns orange-yellow. Hydrogen glows in particular shades of red and blue. By studying the light from a star, scientists can tell exactly what that star is made of, even from billions of light years away. Chemistry is a universal language. The same elements that make up you make up the light arriving from the edge of the visible universe. We are all made of the same small set of ingredients, assembled in different ways, at different temperatures, under different pressures, telling different stories. The light from the sun takes about 8 minutes and 20 seconds to reach us. So the sun you see in the daytime sky is not the sun as it is right now. It is the sun as it was 8 minutes ago. The stars you see at night are not the stars as they are tonight. They are the stars as they were years, decades, centuries, thousands of years ago. When you look at the night sky, you are not seeing a snapshot of the present. You are looking at a layered history, a collage of different moments, all arriving at your eye. At the same time, some of the stars you see no longer exist. They burned out long ago. But their light is still traveling, still carrying the memory of their fire across the dark. There is a thought that sometimes arises in the study of cosmology. If the universe is infinitely large, then somewhere out there, there may be an exact copy of this moment. An exact copy of you, lying still, in a room much like this one, listening to these words. The multiverse hypothesis goes even further, suggesting that there may be an infinite number of universes, each with slightly different physical laws, each playing out a slightly different version of everything. These are ideas that live at the edge of what we can test or verify. They may be right, they may not be, but the act of imagining them has value in itself. It loosens something, the rigidity of what feels permanent, the certainty of what feels fixed. When you consider that this particular arrangement of matter and energy, that is you, lying here tonight, thinking these thoughts, might be replicated infinitely, across dimensions you cannot reach, something about your own existence becomes both smaller and more precious. At the same time, you are rare, or you are everywhere. Perhaps both things are true. Let that softness rest with you for a moment. The number of atoms in the observable universe is estimated at roughly 10 to the power of 80. A number so large, it has no meaningful name in everyday language. And yet every atom follows the same rules, the same forces, the same mathematics. A hydrogen atom in your blood is identical to a hydrogen atom in the farthest galaxy we have ever observed. The universe plays by one set of rules, and life, here on Earth, learned how to use those rules in a particular and remarkable way. It seems hard to believe that life figured out those rules only once. The Kepler Space Telescope, launched in 2009 and retired in 2018, stared at one small patch of sky for years and found thousands of exoplanets. Thousands. By monitoring the tiny dip in starlight when a planet passed in front of its star, a method called the transit method. Imagine you are standing in a field at night, watching a distant window. You cannot see the window clearly, but when a moth flies across it, the light dims by a tiny fraction. That is how we find planets. We watch for the faintest dimming, the quietest passing shadow. And in the patterns of that shadow, we read the size of the world, the distance from its star, the length of its year. The TESS telescope, which followed Kepler, surveys almost the entire sky, looking, finding, quietly accumulating the list of worlds that are out there. The list grows every year. Every month, new planets are confirmed. The universe turns out to be full of places. Almost embarrassingly, full of places. There is a particularly evocative idea called the cosmic calendar. It was devised by Carl Sagan. The idea is to compress the entire history of the universe into a single year. The Big Bang happens on January 1st. Our solar system forms around September 9th. Life on Earth first appears around September 21st. Multicellular life does not show up until the middle of December. Dinosaurs appear on December 25th and are gone by December 29th. Humans, our entire species, all of recorded history, do not appear until the last few minutes of December 31st. The last 10,000 years of civilization happen in the last 30 seconds of the year. We are very new here, very new, and the universe was doing extraordinary things for a very long time before we arrived to notice. Your body knows how to rest. It has been resting for as long as you have been alive. Let it do what it knows. There is a field of chemistry called prebiotic chemistry. It studies the chemical reactions that might have led to the first living molecules on the early Earth. The Miller-Urey experiment in 1952 showed that by combining water, hydrogen, methane, and ammonia, and adding electrical sparks to simulate lightning, you could produce amino acids, the building blocks of proteins, the building blocks of life, spontaneously, without any biology, without any guidance. Just chemistry and energy finding each other in a warm and turbulent world. If the chemistry of life can arise this naturally, then perhaps the question is not whether life exists elsewhere, but how long it takes to get started, and whether, once started, it lasts. RNA, ribonucleic acid, may have been the first molecule capable of both storing information and catalyzing chemical reactions. A molecule that could do two things at once. That could hold its own blueprint and also help build itself. Scientists call this the RNA world hypothesis, and it suggests that before DNA, before proteins as we know them, there was RNA doing the work of both in the warm chemical soup of early Earth. A single molecule doing what it needed to do to keep going. There is something almost admirable about that. Something quietly persistent. The universe does not seem to care whether life exists or not. It has no preference, no goal. It simply does what physics and chemistry require. And yet, out of that indifference, something happened on at least one world that was genuinely unexpected. Life emerged. It grew complex. It developed the ability to ask questions about itself. We are, in some ways, the universe looking at itself and wondering. The universe developing the ability to be curious about its own nature. That thought has stayed with scientists and philosophers for a long time. Carl Sagan put it simply. He said that we are a way for the cosmos to know itself. We are made of star stuff, knowing stars. And somewhere out there, maybe, something else is doing the same thing. Looking up, wondering, sending out a question into the dark. Softer now. Let everything get quieter. The concept of a Type 1, Type 2, or Type 3 civilization comes from a physicist named Nikolai Kardashev. In 1964, he proposed a scale for measuring the technological advancement of a civilization based on how much energy it uses. A Type 1 civilization has mastered the energy of its own planet. Type 2 controls the energy of its star. Type 3 controls the energy of its entire galaxy. By this scale, we are currently about a 0.7. Not yet a Type 1. Still learning to manage what we have here at home. A civilization that had reached Type 2 or Type 3 would be almost incomprehensible to us. It might look less like technology and more like magic or like nature itself, so integrated into its environment that we might not recognize it as civilization at all. One proposed idea for detecting a Type 2 civilization is something called a Dyson sphere. In theory, a sufficiently advanced civilization might build a structure around its star to capture almost all of its energy. Such a structure would not block the star entirely, but would absorb much of its visible light and re-emit it as infrared radiation. We might be able to detect the unusual infrared signature of such a megastructure from our side of the galaxy. There have been a few intriguing stars whose light dimmed in unusual ways, leading to speculation. Tabby's star is the most famous example. It flickered strangely, irregularly, in ways that normal stellar processes did not fully explain. Later studies suggested the most likely explanation was a large cloud of dust and debris. Natural, but for a brief and glittering moment, people wondered. And wondering is not nothing. Outside, wherever you are, the sky is there. It does not need you to look at it, to be extraordinary. It is just there, above you, full of questions. The concept of life being brought to Earth from elsewhere, rather than originating here, is called directed panspermia when applied to intentional seeding. One of the scientists who co-discovered the structure of DNA, Francis Crick, once speculated that life on Earth might have been intentionally seeded by an advanced extraterrestrial civilization. He later distanced himself from the idea. Most scientists consider it unlikely, but the fact that even he, one of the most celebrated scientists of the 20th century, found the question worth asking, says something about how strange the origin of life genuinely is. We still do not fully understand how life began here. We have hypotheses. We have experiments. We have pieces of the picture. But the moment when chemistry became biology, when a molecule first made a copy of itself, and we call that moment the beginning of life, that moment is still somewhat mysterious. And perhaps it is right that it stays that way for a while longer. Some mysteries deserve to be held lightly before being resolved. Titan is another of Saturn's moons. It is larger than the planet Mercury. It has a thick atmosphere, a real one, denser than our own. On Titan it rains, not water, liquid methane. Rivers of methane carve channels into the surface. Lakes of liquid methane sit quietly in the polar regions. It is, in the most alien way, familiar. A world with weather, with seasons, with a thick, complex atmosphere. Could something live in those methane lakes? Using methane the way we use water? Breathing hydrogen instead of oxygen? It is speculative, genuinely speculative. But scientists have modeled what such life might look like chemically. And the answer is not impossible. NASA is planning a mission to Titan. It is called Dragonfly, a drone, a rotorcraft lander that will fly through Titan's thick atmosphere and explore its surface. It is expected to launch in the coming years and arrive at Titan in the 2030s. It will land in different locations, sample the chemistry, look for the signs of something interesting. It is a long journey to a cold and distant moon, but the question is worth the travel. There is a researcher named Jill Tarter who spent decades leading SETI research. She has said something that stays with me. She has noted that we have been searching for only about 60 years in a universe that is nearly 14 billion years old. We have examined a tiny fraction of the radio spectrum, a tiny fraction of the sky, for a tiny fraction of time. The fact that we haven't found anything yet tells us almost nothing. It is a little like scooping a glass of seawater from the ocean and concluding that there are no fish. And there is something comforting in that image. The ocean is full. We simply haven't looked very far yet. The night is getting quieter now. Or perhaps you are. It is hard to tell, sometimes, the difference. Water has a chemical formula, so simple it is almost surprising. 2 hydrogen atoms and 1 oxygen atom. H2O, one of the most common molecules in the universe. Water has been detected in clouds of gas between stars. It coats the surfaces of comets. It exists as ice on moons and asteroids throughout our solar system. It is everywhere. And life, as far as we can tell, goes wherever water goes. If that pattern holds, beyond our little corner of the galaxy, the universe may be considerably less lonely than it feels on a quiet night. Oxygen itself is the 3rd most abundant element in the universe, after hydrogen and helium. It does not exist freely in most places, because it tends to bind quickly with other things. But the raw ingredient is extraordinarily common. The building blocks are not rare. They are scattered across the galaxy like grains of sand. Carbon is the backbone of life on Earth. It forms the most complex and varied molecules of any element. It bonds with itself and with other elements in a dizzying number of configurations. Carbon-based molecules have been found in interstellar space, in comets, in meteorites, even in the clouds of gas surrounding young stars. The chemistry of life begins long before a planet even forms. It forms in the cloud. It rides the comet. It waits in the rock. Patient, ready. The universe is very old and very patient. Your body is resting well now. Every breath a little slower than the last. There is a concept in astronomy called the galactic habitable zone. Just as a star has a habitable zone around it, our galaxy may have a habitable zone as well. The center of the Milky Way is dense with stars and radiation and gravitational disturbances. Life there might struggle. The outer edges of the galaxy are sparse and metal poor, lacking the heavier elements that rocky planets need. The galactic habitable zone is thought to be a ring of space between those extremes. A zone where there are enough heavy elements to build rocky planets, but not so much violence that complex life would be disrupted. Our sun sits comfortably in that zone, as does, apparently, our little world. One of the most important factors that allowed complex life to develop on Earth may have been our moon. Our large and relatively nearby moon stabilizes the tilt of Earth's axis. Without it, that tilt might wobble dramatically over long periods of time, causing extreme variations in climate that could destabilize the conditions. Life needs to evolve over billions of years. The moon also creates the tides, and some scientists have suggested that the rhythmic rise and fall of tidal zones may have been important for the chemistry that led to life. We often take the moon for granted, a pale round thing in the sky, a backdrop for poems. But it may have been, in a very real sense, one of the reasons you exist. Jupiter may also have played a role. The largest planet in our solar system acts as a gravitational shield. Its enormous mass pulls in or deflects many of the comets and asteroids that might otherwise strike Earth. It is not a perfect shield. Earth has been struck many times, but without Jupiter, those strikes might have been much more frequent, much more catastrophic. The development of complex life over hundreds of millions of years may require a certain amount of planetary stability, and that stability on Earth may owe something to a large, cold, distant giant quietly doing its gravitational work, far out in the dark. We exist because of 1,000 fortunate things. Or perhaps the universe is so large that given enough tries, every combination eventually occurs. Either answer is worth holding lightly in the night The radio signals we have broadcast from Earth, accidentally and on purpose, have been expanding outward in a sphere for about 100 years now. That sphere reaches approximately 100 light years in every direction. It includes perhaps a few thousand star systems in a galaxy of 400 billion stars. If someone is listening right now, at the edge of that sphere, what are they hearing? The earliest radio broadcasts, the crackle of the first television transmissions, the accidental noise of a species, just discovering how to talk to itself across a distance. We did not send that sphere intentionally. It just leaked out, the way heat leaks through a window. On a winter night, there are debates within the scientific community about whether we should be transmitting at all. Some scientists argue that broadcasting our location to the cosmos without knowing who is listening is a risk not worth taking. Others argue that any civilization capable of reaching us already knows we are here, that the accidental leakage of our radio signals has already made us visible. The debate is real, and genuinely thoughtful people land on different sides of it. For now, we mostly listen rather than shout, which seems, in the circumstances, a reasonable approach. Your breathing is slow, quiet, easy. Your body knows what it needs. There is a phrase that comes up in the study of extremophiles. Life finds a way. It sounds like a platitude, but as a statement about biology, it is practically a law. On Earth, life has colonized every environment it has ever come into contact with. Deserts, ice sheets, deep ocean floors, the upper atmosphere, the walls of nuclear reactors, even, reportedly, the interior of spacecraft in Earth orbit. Life, when given chemistry and energy, and even a small amount of time, tends to make itself at home. Observatories on Earth are increasingly being built at extreme altitudes, high in the Atacama Desert in Chile, atop the dormant volcanoes of Hawaii, in Antarctica, places where the atmosphere is thin, the air is dry, and the interference from human technology is minimized. We climb as high as we can to get the clearest possible view, to reduce the noise, to get a little closer to the silence. It is a form of straining toward something, a civilization leaning forward into the dark. The extremely large telescope, currently being built in Chile, will have a primary mirror, about 39 meters across. When it is complete, it will be able to directly image some exoplanets, not just detect their transits, but actually see them as disks of light. Small, faint disks, but disks nonetheless. Worlds seen directly, for the first time. And from those images, if we are very careful and very lucky, we might begin to see their colors. And from their colors, we might begin to guess whether anything is growing there. On Earth, plants and photosynthetic organisms create what scientists call the vegetation red edge, a specific way that certain wavelengths of light are reflected from living plant material. If we observed that same pattern in the reflected light of another planet, it would be a quiet, careful, genuinely exciting signal that something might be growing. Not proof, never proof, not yet, but a signal, a soft and hopeful reading in the light. The night folds around you gently, like water, like a gentle tide going out. There are scientists who think the discovery of even microbial life beyond Earth would be among the most significant events in human history. Not just scientifically, philosophically, spiritually. The realization that life is not unique to Earth would change something fundamental about how we see ourselves. We would still be us, still on our small world, still dealing with all the ordinary difficulties of being human. But we would know, definitively, that life is a feature of the universe, not an accident that happened once, but a thing that happens. And if it happens more than once, it might happen everywhere. That is a thought that tends to arrive quietly and then sit very still. Once it does, the way our eyes adapted to light is interesting when you think about life elsewhere. Eyes evolved on Earth to detect the wavelengths of light that our sun produces most abundantly. We see in the part of the spectrum where our star is brightest. On a world orbiting a red dwarf star, a living thing might have eyes, sensitive to infrared wavelengths. Eyes designed to see. In what we would call the dark, a world lit by a dim red star might look perfectly bright to the creatures living there. They would look at the kind of light we use and see almost nothing. Senses are not universal. They evolve to fit the world that made them. Intelligence itself may take many forms we would not recognize. The octopus, for example, has a nervous system that is nothing like a mammal's. Much of its intelligence resides in its arms, not its central brain. It sees polarized light. It can change the color and texture of its skin in milliseconds. It solves problems in ways that are utterly different from the way we would approach the same problem. And yet we recognize it as something very like intelligent, something present and curious and awake. If intelligence this different can evolve on our own planet, the range of minds that might exist across the cosmos is extraordinarily wide. There may be minds out there so different from ours that we would not even recognize them as minds. And there may be minds so similar that a conversation with them would feel natural. We do not know which possibility is more likely, or whether both are. In 1973, astronomer John Ball proposed what he called the zoo hypothesis, the idea that extraterrestrial intelligences may already be aware of us and are simply choosing not to interfere. Watching quietly, as a species that puts radio collars on bears and watches them from a distance, without making itself known. It is not a mainstream hypothesis. Most scientists prefer explanations that do not require a conspiracy of silence, maintained across potentially thousands of civilizations. But it is a thought that lingers gently in the mind at night. What if they know about us and are simply waiting? Waiting for us to reach some threshold, to stop fighting, to stop burning things, to look up together and say, "Hello." Let the thought drift. You do not need to solve it. Just let it float. There is a debate in science about whether the conditions for life on Earth were typically fortunate or exceptionally rare. This is sometimes framed as the rare Earth hypothesis. A book by Peter Ward and Joe Kirschvink argued that the precise combination of factors that allowed complex life to develop on Earth, the right kind of star, a large stabilizing moon, a protective gas giant, a position in the galactic habitable zone, plate tectonics to recycle nutrients, a magnetic field to deflect radiation, might be so rare as to make complex life essentially unique to Earth. Simple microbial life might be common. Animals and intelligence might be extraordinarily rare. Other scientists disagree. They argue that evolution is creative enough to find paths to complexity through many different routes. That intelligence is not a specific destination, but a general tendency of sufficiently complex life that, given enough time and enough worlds, brains, are an almost inevitable outcome. Both arguments have merit, and both remain genuinely open. The universe does not seem to be in a hurry to answer. There is something called the anthropic principle. It is the observation that the universe we observe must be compatible with our existence. In other words, if the laws of physics had been even slightly different, we would not be here to notice. The constants of nature, the strength of gravity, the mass of electrons, the speed of light, seem to be tuned to values that allow stars to form, elements to accumulate, and life to emerge. Change any of them significantly, and the universe produces no stars, no planets, no chemistry, nothing. Just hydrogen expanding into eternal dark. What does it mean that we find ourselves in a universe precisely tuned to permit our existence? Some take it as evidence of design. Others say it is simply the selection effect. Of course, we live in a universe that permits life. Any other universe would have no one in it to ask the question. Either way, the fact that these numbers line up just right is one of the quieter mysteries that science keeps coming back to. You are here. That is not nothing. In a universe that could have been, empty and cold and still, something arranged itself into you. Something curious and complicated and warm. Your breath fills the room and leaves it gently. There are missions currently being planned to send a spacecraft to Europa. NASA's Europa Clipper mission, launched in October of 2024 and is now traveling toward Jupiter. When it arrives, it will make dozens of close flybys of Europa, studying its icy surface, measuring the magnetic field, tasting the plumes of material that may be erupting from the ocean below. It will not land. It will not drill through the ice. It will just pass and look and listen. But what it sees might tell us more about that hidden ocean than anything we currently know. If life exists in Europa's ocean, it has been there in darkness for an enormous amount of time. Billions of years, perhaps, with no sunlight, no sky, no seasons, just the slow chemistry of a buried sea. If we found life there, it would tell us something beautiful. That life does not need a sun, that it does not need seasons, or a sky, or a view of the stars. It just needs chemistry, and energy, and time. And of those three things, the universe has an enormous and patient supply. The silence of the universe, if you choose to hear it that way, is not emptiness. It is more like the silence of a library, full of things, full of information, waiting to be read. We have only just learned how to hold the book. In the history of science, the things that turned out to be true were almost always more remarkable than the things that turned out to be false. We thought the Earth was the center of everything. It was not. We thought our galaxy was all there was. There are 2 trillion of them. We thought life needed sunlight. It does not. We thought DNA was too complex to have arisen naturally. It arose. Every time we have looked at the universe and said, "Surely this is as strange as it gets," the universe has found a way to surprise us. There is no reason to think it will stop doing that. Let that thought be soft. Let it settle gently at the edge of sleep. The stars are enormous, even the ones that look like tiny pinpricks in the night sky. Our own sun is about 1.4 million kilometers across. The largest stars we know of, called hypergiants, are so large that if you placed one where our sun is, it would swallow the orbits of Jupiter, Saturn, Uranus, and Neptune. Everything in the inner solar system, Earth included, would be inside the star. And yet, even those enormous stars are tiny compared to the distances between them. Space is mostly space, mostly emptiness, mostly a vast and dark quiet, with occasional islands of matter. The ratio of star to void is almost incomprehensibly small. which makes the universe, in a certain sense, very empty, and very cold, and very dark, but also full of these small and burning islands, these patient furnaces, these generators of light and heat, and the heavy elements, from which everything we know is made. There is a kind of comfort in scale, when everything feels too large, and too overwhelming when the problems feel enormous, and the night feels very long. There is something restful about remembering that you are a very small thing in a very large place, that the universe has been doing its patient work for nearly 14 billion years, long before you arrived, and will continue long after. And in the middle of all that, you get to be here. You get to breathe, to rest, to wonder. That is a gift. A small, quiet, remarkable gift. The question of whether we are alone will probably not be answered tonight, or this year, perhaps not in our lifetimes. But the search continues, quietly, carefully, with instruments that grow more sensitive with each passing year. Each new telescope, each new mission, each new paper, peeling back one more layer of the question. The answer, whatever it turns out to be, is already out there, written in the chemistry of some distant world, encoded in a signal, still drifting through the dark. Or perhaps written only in the silence itself. And silence is not nothing. Silence has depth. Silence has texture. In silence, things are always happening. You just have to listen differently. Let your eyes close, if they haven't already. Imagine the universe from a distance. If such a thing were possible, if you could somehow step back and see it whole. A vast web of filaments, and clusters, and voids. Galaxies gathered in long, curved threads, separated by enormous stretches of almost nothing. It would look, from a distance, a bit like a neural network, like a brain, like the structure of thought itself. Scientists who study the large-scale structure of the universe often note this resemblance. The cosmic web and the neural network look strangely similar. What that means, if it means anything at all, is one of those questions, best held loosely. But it is a beautiful symmetry. The small and the vast, rhyming with each other. You, lying here, contain within your brain approximately 86 billion neurons, each connected to thousands of others. The number of possible connections in a human brain exceeds the number of stars in the Milky Way. The universe inside you is, in some sense, as complex as the universe outside you. One of them contains galaxies. The other contains the memory of learning to walk, the sound of your favorite song, the warmth of a childhood room. Different scales, same kind of intricate, improbable beauty. We look out at the cosmos and ask if we are alone. But perhaps the cosmos is already inside us. The elements of it, the math of it, the strange, improbable fact of it. Every atom of carbon in your body has been here since before the Earth formed, long before, passing through stars, drifting through nebulae, part of ancient rocks, part of ancient seas, part of things long gone. And now, for a while, part of you, the atoms that are you, will, eventually, be part of something else. They will not disappear. Atoms do not disappear. They simply move on into the soil, into plants, into the air, into other creatures, perhaps someday into the sea, and someday, very much later, back into the stars. Nothing is wasted. Nothing is lost. It only changes form. That is not frightening. That is quietly beautiful. There is a kind of peace that comes from understanding your size. Not a diminishing, not a defeat, but a settling, a recognition that the universe has been doing this for a very long time and knows what it is doing. That you are part of it, not separate from it, not observing it from the outside, but woven into it, a particular and temporary arrangement of the same matter that makes everything. Let that settle. Let the weight of the world become the weight of the universe. And then let the universe hold you. If there is life elsewhere, it is made of the same stuff. It follows the same mathematics. It exists in the same expanding space, whatever form it takes. It cannot be entirely alien. The rules are the same everywhere. The physics does not change from one side of the galaxy to the other. And those rules, strange as they are what we share with everything that has ever existed. Maybe we are not so alone as the silence suggests. Maybe the universe is full of lives that have not yet found a way to say hello, separated not by hostility, but simply by distance, by the vast and unhurried scale of space. And maybe that is all right. Maybe it is enough, for now, to simply know that the question is worth asking. That we live in a universe where the question can be asked, where something curious and alive looks up and wonders. That is the quiet miracle of tonight. Not an answer, just the wondering, just the soft and open question, drifting up through the dark, toward the stars. You do not have to hold it. Just let it go. Let it drift, like a message sent across an enormous distance. Patient, unhurried, trusting in the size of thing. The room around you is still. The dark is gentle. Your body is warm and heavy and completely at rest. You have traveled, in your mind, across distances that no human body could ever cross. You have visited icy moons and distant stars and the ancient beginnings of chemistry. And now you return to this room, to this breath, to this quiet body lying still in the dark. The universe is still out there, all of it. The 2 trillion galaxies, the billions of planets, the ancient light still traveling, the cold and patient moons, the radio dishes tilted gently toward the stars. All of it continuing, as it always does, quietly, without hurry, without alarm. And you are part of all of it. Even now, resting here, your atoms humming with the same physics that makes stars. If you haven't closed your eyes yet, let them close now. Softly, without effort. Just let them find their way to darkness. The question of whether we are alone will wait for us. It has waited for centuries. It can wait until morning, or longer. Tonight, you have earned your rest. Tonight, the universe can hold its own mystery while you sleep. And the stars will be there when you wake. Every single one of them, patient, ancient, still burning, still carrying their light across the dark in your direction. Sleep well. There is a kind of mathematics that astronomers use to understand the size of things. It is called scientific notation, a way of writing very large numbers without endless strings of zeros. But no notation really conveys what it feels like to understand these numbers in your body. The observable universe is roughly 93 billion light-years across. A light-year is the distance light travels in 1 year at 300,000 kilometers per second. For 365 days, that is approximately 9.5 trillion kilometers per light-year, and the universe is 93 billion of those across. You cannot hold that number. No mind can, and that is all right. You do not need to hold it. You just need to feel its weight settling around you like a blanket. Something that does not get mentioned often enough in the search for extraterrestrial life is how recently we developed the tools to look. Galileo built his first telescope around 1609, just over 400 years ago. Before that, the stars were just lights, beautiful and mysterious, but without detail, without depth, without the suggestion that they were other suns. It was only in the 20th century that we confirmed other galaxies existed. Only in 1992 that we confirmed other planets. Only in recent years that we began to read the air of those planets. We are infants, in cosmic terms, at this particular task. infants with extraordinary curiosity, and increasingly powerful instruments, but infants nonetheless. One of the most thought-provoking aspects of the search for life is what we might call the time problem. Two civilizations could exist in the same galaxy and still never overlap. Not because of distance, but because of time. If one civilization rose and fell before the other began, they might be separated, not by space, but by billions of years. Ships passing in the night, except the night, is 13 billion years long. This gives a different color to the silence. It may not be that the universe is empty. It may be that the universe is full of civilizations that simply did not exist at the same time, separated by the most impassable barrier of all, not distance, but time. There is something quietly sobering about that, and something quietly freeing, because it means that even our absence of contact does not tell us much. The universe is so old, and we are so new, that the silence might be nothing more than a timing issue. The night presses softly. The air is still. Everything is quiet. There is a molecule called glycine. It is the simplest amino acid, one of the building blocks of proteins, and therefore one of the building blocks of life. In 2009, scientists confirmed the detection of glycine in samples returned from a comet. Comets, which are essentially dirty snowballs, left over from the formation of our solar system, may carry amino acids across the solar system and potentially deposit them on planets. The building blocks of life, hitching rides on frozen travelers, drifting through the solar system for billions of years, waiting for a warm world to catch them. The Rosetta mission, launched by the European Space Agency, became the first spacecraft to orbit a comet and land a probe on its surface. In 2014, the Philae lander touched down on Comet 67P, Churyumov-Gerasimenko. The comet was dark and rough and shaped like a rubber duck, and it contained complex organic molecules, including some never before detected in a comet. The chemistry of life is everywhere we look, every time we look, with good enough instruments. There is a concept in astrobiology called the window of detectability. It refers to the period of time during which a civilization produces detectable signatures. A civilization in its earliest stages might not be detectable at all. No radio signals, no industrial chemicals in the atmosphere, no light pollution on the night side of the planet. A civilization in its later stages might have moved beyond the technologies we know how to detect. There may be a narrow window, relatively brief on cosmic timescales, during which a civilization is both technologically active and detectable by the methods we are using. And we may be in that window right now, sending out our signals, waiting for someone who is also in their window, to notice. But windows are only open for a while. In the middle of the 20th century, a man named Konstantin Tsiolkovsky anticipated a version of the Fermi paradox, decades before Fermi asked the question. He noted that if an advanced civilization wanted to colonize the galaxy and had access to even modest technology, it could do so in a cosmically short amount of time. Millions of years, perhaps. Tens of millions at most, against the age of the galaxy, which is about 13 billion years, that is practically overnight. If even one civilization had begun this process 1 billion years ago, the galaxy might already be colonized. And yet it does not appear to be. We see no megastructures. We find no ancient probes. We hear no old broadcasts. Which leads back, always, to the same quiet question: where is everybody? And the silence answers, as it always does, with silence. There is something restful, actually, in that silence, in the fact that the answer is still open, still possible, every direction still pointing toward something unknown. It means the universe has not run out of surprises yet, not for us, not tonight. Your body is very still now. You're breathing very slow. The edges of the room have grown soft. One of the things that makes the search for extraterrestrial life so compelling is that it is not just a scientific question. It is a question about meaning, about whether we are the kind of universe that produces life as a matter of course, or whether we are the kind of universe that produced it once, in a remarkable accident. And those two answers lead to very different feelings about what it means to be here. If we are alone, then every breath you take is part of the only conversation the universe is having with itself. Every thought you think is one of the only thoughts in a universe that might otherwise be entirely without them. That is a weight, but also a strange kind of honor. If we are not alone, if life runs through the cosmos, the way water runs through a landscape, finding every low place, filling every available hollow, then the universe is a kind of garden, full, varied, patient, and we are one flower in it. Small, but real, part of something larger than we can see. Both answers, actually, end in the same place. Here, in this room, on this planet, in this breath. Whatever the universe contains, you are in it. You are of it. You belong to it, as completely as a star belongs to its galaxy. The history of astronomy is a history of displacement. Each new discovery moved us a little further from the center of things. The Earth is not the center of the solar system. The Sun is not the center of the galaxy. The galaxy is not the center of the universe. The universe may not even be the only universe. At every step, we thought we were special. At every step, we found out we were smaller than we had imagined. And yet, something in us keeps looking, keeps asking, keeps building telescopes and sending probes and listening to the dark. That impulse, that quiet and persistent curiosity, may be the most remarkable thing about us. Not our size, our wondering. There are researchers who study what they call technosignatures. Not biosignatures from biology, but signatures from technology. The kind of things a technological civilization might leave behind. The spectral signatures of industrial chemicals in an atmosphere. The excess infrared radiation of a civilization generating a lot of heat. Unusual artificial lighting on the night side of a planet. Signs of large-scale engineering on a planetary surface. These are all things we are beginning to look for. Things we would only see if someone else out there had developed at least as much technology as we have. Maybe more. The question of whether a civilization would choose to make itself visible is interesting. Perhaps some civilizations would deliberately hide, go dark, reduce their energy output, make themselves invisible against the background noise of the cosmos. Not out of fear, necessarily, but out of wisdom, having learned something that we have not learned yet. Or perhaps out of discretion, the way a person sometimes goes quiet, not because they have nothing to say, but because they have decided that listening is more valuable for now. There is a concept called the dark forest theory. It is named after a novel and proposes something more unsettling, that the reason the universe is quiet is because every civilization that survives learns to go silent for its own protection. That the universe is not empty, but full of civilizations, hiding in the dark, watching and listening, and keeping very still. This is a minority view. Most scientists do not find it the most likely explanation, but it is worth mentioning as an example of how many different answers could fit the same silence. The data we have is compatible with almost everything. Loneliness and abundance. An empty universe and a full one. We simply do not have enough information yet to choose. So we keep looking. Quietly, carefully, with the instruments we have. The Square Kilometre Array is a radio telescope project currently being built in South Africa and Australia. When complete, it will be the largest radio telescope ever built. An array of thousands of receivers spread across 2 continents, working in concert. It will be sensitive enough to detect a signal from the other side of the galaxy that no existing instrument could find. It will survey the sky in ways and at speeds never before possible. If there is something to hear, in the radio spectrum, this instrument will be the first with a real chance of hearing it. But radio is not the only way we search now. Optical SETI looks for brief pulses of laser light from distant stars. Lasers are efficient, directed. In principle, a laser pulse bright enough to outshine a star for a fraction of a second could be detectable from light years away. Some SETI researchers believe that lasers, rather than radio waves, might be the communication medium of choice for a sufficiently advanced civilization. And so some telescopes now watch specifically for those brief, bright, directed flashes, patient as ever, waiting, watching. Your thoughts are slowing now. You can feel them, softer at the edges, less urgent. That is a good sign. Let them slow further. The Milky Way is a barred spiral galaxy, which means it has a central bar-shaped structure of stars and gas, with spiral arms extending from it. Our solar system sits on one of those arms, the Orion Arm, about 2/3 of the way from the center to the edge. We cannot see our galaxy from the outside. We are inside it, the way a fish cannot see the ocean from above. But by mapping the positions and movements of stars around us, we have built a picture, a rough but genuine picture of the great wheel we are spinning inside. And somewhere on that wheel, perhaps there are other worlds where something lies still in the dark and wonders about us. The idea of first contact, of actually making contact with another intelligent species, is something humanity has imagined in countless ways. In stories, in films, in philosophy, in religion. Almost every culture on Earth has a tradition of contact with beings from somewhere else. Spirits from the sky, gods descending, ancestors returning from above. The shape of the story varies, but the longing it reflects is remarkably consistent. We have always wanted to know if something is out there, looking at us, aware of us, perhaps even glad of us. The protocols for what to do if we actually detected a signal from another civilization are surprisingly thoughtful. There are internationally agreed guidelines. The detection would first need to be confirmed by independent observatories, then announced to the scientific community, then to governments, then to the public. And before any response was sent, there would need to be international consultation, because any reply we send would represent not one nation, but all of humanity. It is one of the few situations in which every living person has a stake. What would we say? If given the chance, if the quiet finally broke, if a signal arrived that was unmistakably, undeniably someone, What would we choose to say on behalf of all of this? Perhaps just, we are here. We are wondering. We did not know about you, but we hoped. Or perhaps it took us a long time to figure out how to listen. But we are listening now. The universe is very old and still becoming, still expanding, still forming new stars. In about 5 billion years, our sun will exhaust its hydrogen fuel and expand into a red giant, swallowing the inner planets. In about 7 billion years, the Milky Way and the Andromeda Galaxy will begin to merge, a slow collision that will play out over billions of years. What the night sky will look like from Earth in a billion years, if anyone is here to see it, is something worth trying to imagine. Andromeda growing slowly larger, a smear of light across the entire sky, the two galaxies beginning their long and gentle entanglement. Stars will not collide. They are too far apart within each galaxy. It will be a collision of gravity, more than matter. A gravitational dance, long and slow, and eventually settling into a new and larger galaxy with a different shape. The stars, mostly, will simply find new orbits, new positions in a new structure, rearranged, but still burning. Even merging galaxies do not end the individual stories of their stars, just the story of their arrangement. You are a particular arrangement of matter and energy that has never existed before and will never exist again. Not exactly. Not in this precise configuration. Not with this particular combination of experiences and memories and neurons firing in this particular pattern. The universe made you exactly once, and it will not repeat the experiment. That is not sad. That is extraordinary. Rest in it. Rest in the extraordinary particular fact of being you. There is a thought experiment, sometimes called the cosmic perspective. It asks you to imagine looking back at Earth from increasingly great distances. First from the Moon, then from Mars, then from the outer solar system, then from the edge of the solar system, where Voyager is now, then from the nearest star, then from the center of the galaxy. At each step, Earth shrinks, becomes less distinct, less central, eventually invisible. The thought experiment is not meant to make you feel small and unimportant. It is meant to do something more nuanced, to help you see that the things which feel enormous here, the arguments, the worries, the urgencies, are local, contained within that pale blue speck, and that the speck itself is not diminished by being small. It is cherished, perhaps, by the very fact that it is all we have. The speck is home, and home is worth more than its size suggests. There are experiments underway right now as you lie here resting, designed to detect biosignatures in the atmospheres of exoplanets. The James Webb Space Telescope is observing planet K218b, a planet about 120 light-years away, and has found intriguing signs in its atmospheric chemistry. Not conclusive. Not yet, but interesting enough to look at very carefully. The atmosphere contains carbon dioxide and methane, and potentially dimethyl sulfide, a molecule that on Earth is primarily produced by marine microbes, phytoplankton in the ocean, tiny, drifting, photosynthesizing organisms that fill the surface of the sea and produce that faint ocean smell. If that signal holds up, if future observations confirm it and rule out other explanations, then we may be looking at a planet with an ocean full of life. 120 light-years away, completely unreachable, but visible, detectable, known. That would be the most significant discovery in the history of science, possibly in the history of our species. And it would arrive not with a fanfare, but with a careful and cautious reading of a spectrum of light. We are that close, perhaps, to knowing, and perhaps not. Perhaps the signal will turn out to have another explanation. Perhaps we will have to wait longer. Science does not mind waiting. Science has been waiting since the beginning. Each wrong answer leading more precisely toward the right one. Your breath is like a tide, in and out, soft and regular, just the way the universe has always intended. It is worth thinking, just briefly, about the scientists who dedicate their lives to this search. They sit in control rooms and sift through vast quantities of data. They write papers. They attend conferences. They build instruments that take decades to design and fund and deploy. Many of them will retire without finding an answer, and they know this going in. They work not for the prize of the discovery, but for the value of the search itself, for the simple conviction that the question deserves to be asked as carefully as we can ask it. That feels like a kind of love, a love directed outward, toward the dark, toward whatever might be there. The pioneers of this field, Frank Drake, Jill Tarter, Carl Sagan, had no guarantee of success. They built the framework anyway. They asked the question as rigorously as they could. They did the math. They built the instruments. They listened, and they passed the listening on to the next generation, who passed it on again. And so it continues, patient and hopeful, and unafraid of silence. The silence does not mean no. It only means not yet. There is an old idea in philosophy that might be worth holding gently as you drift towards sleep. It is the idea that the universe tends toward complexity, that given enough time and energy, matter naturally organizes itself into more and more intricate forms. Simple atoms forming molecules, molecules forming cells, cells forming organisms, organisms forming ecologies, ecologies forming the conditions in which minds emerge. If this is a general tendency of matter, and not just a peculiarity of Earth, then minds may be not a fluke, but a direction, a thing the universe moves toward, slowly, quietly, over billions of years, but inexorably. That is, in the kindest possible sense, a hopeful thought. The stars above you tonight are the same stars that sailors navigated by, the same stars that ancient humans watched from their fires, the same stars that have been there for billions of years, burning their patient fires, whether anyone was watching or not. They do not know they are beautiful. They do not know they are old. They do not know that something on a small planet, far out in one of their spiral arms, is lying still in the dark and thinking about them. But they are there, constant, ancient, indifferent, and somehow deeply comforting. Let the thought of them settle over you like a blanket, warm and vast and very still. You do not need to solve the universe tonight. No one does. No one can. It has been here for 13.8 billion years, and it will be here long after all our questions have been answered or forgotten. The universe is patient with us. It does not rush. It does not need us to understand it, to continue being magnificent. It just is. And you are in it. And you are part of it. And right now, you are resting, which is exactly the right thing to be doing. The darkness around you is ancient. The same darkness that has been here, between the stars, since the beginning. Darkness is not nothing. It is the space in which things happen, the canvas on which the light is painted. Without the dark, the stars would be invisible. Without the silence, no signal could be heard. Even the questions we ask need a quiet moment to be heard. Tonight, the dark is yours. The quiet is yours. And the questions can rest right alongside you. If you are still awake, that is fine. Let each breath carry you a little further from the surface, a little deeper, down through the layers. The thinking and the planning and the worrying, all softening, all receding like a tide going out, leaving behind only the clean, quiet sand of your resting mind. Somewhere out there, the radio dishes are still listening. The telescopes are still watching. The spacecraft are still traveling. The scientists are still working, or sleeping, or dreaming of what they might find. The universe is still expanding, still cooling, still arranging its matter into new and interesting patterns. Somewhere, perhaps, something is alive and looking up, perhaps wondering whether anyone else is out there, perhaps asking, in their own way, the same question you are drifting away from as you fall into sleep. Maybe you are the universe, thinking about itself tonight. Maybe that is enough. Maybe that has always been enough. Let your body go. Let your thoughts go. Let the question go. And let the silence that has held the stars for billions of years hold you now, gently, completely, without asking anything of you at all. You are a small and beautiful thing in a very large universe, and the universe does not mind at all that you are resting. In fact, for just this moment, the whole vast silent universe seems to settle around you like a quiet breath.